All right, good day everybody viewing to this video right now. My name is Ibenagum Julius, popularly called Julie Ben. I happen to be a PhD student in the Nnamdi Azikiwe University, and Professor Reko Koye happens to be my supervisor. And I am here to showcase a generator that doesn't make use of fuel, that doesn't make use of water, that doesn't make use of oil. It is carbon free, it doesn't produce carbon monoxide. That is the generator I am here to showcase. This project work actually took me almost a decade to achieve. I started thinking about this since 2014, the possibilities of making this research work a feasible one. And I decided to take it at this PhD level as a partial fulfillment of my doctorate program. However, if it doesn't scale through, no problem. I will have to get into other research works and make sure that I get that doctorate program as soon as possible. Now, this is an amazing research work and it comes with amazing options. The gospel truth about this design didn't just happen all of a sudden. I passed through quite a whole lot of challenges from my peers, from people within, from people outside, and at a point I got discouraged. I seriously got discouraged. To be sincere with you, I got discouraged in the process of running this project work. Now, but in my discouragement, at the point of giving up everything, I received a call from my supervisor. And he called me, Professor Reko Koye, he called me and said, listen to me, Julius. There is no project work, there is no work done that is 100% perfect. In other words, no work is perfect. There is always room for improvement, there is always room for criticism. And that idea, that advice sank into my subconscious. And indeed, I nodded my head and said yes. Even though I was about to give up, this is the time to kick off again. After all, even Michael Faraday, the founder of electric current over 200 years ago, through his principle of electromagnetic induction, he's a founder of electric current, he's a father of physics, yet his work was not perfect. That's the truth. Because in his research, he only discovered the existence of current when a coil or a metallic wire is brought into a magnetic field. So that was the birth of electricity, but it was not perfect in itself because Lenz came into play and said, well, in as much as there is electric current induced in a magnetic field, he has to discover the direction of induction. So if Michael Faraday's research was perfect, then there would have been no room for Lenz. And even Lenz's rule that actually was in accordance with the laws of Newton, the law of conservation of mass and energy and all that, it was still not perfect because if it was, there would have been no need for Fleming's left-hand rule and right-hand rule. In as much as the direction is in the opposite direction to the flow of current, as Lenz said, Fleming's made us to understand the angle of opposition, which was 90 degrees. He said when the thumb and the middle finger, the index are mutually arranged at 90 degrees to each other, this pointing in the direction of force, this pointing in the direction of magnetic field, that this middle finger will point in the direction of current for AC. Then for DC, the left-hand rule. So no work indeed is perfect. Thank you very much, sir, for this encouragement, and at this point I have to show you the work I have done so far so that we know how to take it from there. Boom. Alright, so this is an overview of how everything looks like. Here the DC, the generator is fully complete. This is a panel. This is just an overview before I explain how each principle works. Just have an idea of how it looks like. Interesting. Alright. So very quickly, we are going to start the introduction and how everything works. So the basic component that makes us this fuelless generator I've been talking about is number one, this is the alternator made up of a stator winding and a rotor. Then this is the DC motor, and then next is the battery. Then the final major component is this solar panel. Good. The function of this is to produce AC current through the rotation of the rotor inside the stator winding. And what powers the stator winding to rotate is the DC motor. Now, what powers the DC motor to rotate so as to rotate the stator winding, the rotor winding, is the battery. Now, what charges the battery is the AC current coming from the alternator. And what also charges the battery is the current coming from this setup. Now, the essence of this is to prevent your battery from running down. Because if your battery runs down, definitely this will be affected. The revolutions will decrease and this will also be affected. At the end of the day, you won't have enough output. So the essence of this charging system, this on its own has the ability to charge this battery, but the rate at which this charges the battery is not equal to the rate at which it discharges the battery. And because of that, you need another system that can perpetually charge the battery so that your battery can always be at full capacity to serve you anytime you are in need of it. That is the essence of this combination I have to design here. So, however, just in few details, if you go into this, you are going to see a stator winding and a rotor. The electric current produced here is produced based on Michael Faraday's principle of electromagnetic induction. Michael Faraday made us to understand that by the time a wire is brought into a magnetic field, what happens is that if you move that wire to and fro, an EMF is induced in the system. If you rotate, an EMF is induced in the system, and the speed of rotation also increases the amount of EMF induced, which is a current induced. So that is a concept that brings about this. Now, for the rotor to rotate within this stator winding, you need this DC motor. Now, the capacity of this stator winding and rotor called alternator is about 3,000 revolutions, so as to give you approximately 230 volts worth of voltage. Now, you will have to take a DC motor that is slightly higher than the number of revolutions required by this alternator. And if you check vividly, this is a DC motor of 3,500 revolutions. It is 2 horsepower and it is powered by a 12-volt battery. And that is how this battery does the job. So the extra 500 revolutions it makes per minute is in case you are loading this generator, so that the number of revolutions will not totally shut down below the required revolutions for this battery. And that is why it should be a step higher. Now, in the course of using this battery, you must make this DC motor, you must make sure that you are using a 12 volt. If it is 24 volt, you won't get it right. You have to use a 12 volt battery. It can be 25 amps, it can be 50 amps, it can be 75 amps, 100 amps, 220, whatsoever. It is just capacity difference. The voltage is the same, which is exactly 12 volt, which will power this. Now, before you are able to get AC current which you can use at home from here, what happens is, as soon as the rotor rotates within the stator winding, electric current is induced into the stator winding, and the stator winding will output the current through these 6 terminals. You have red, black, you have brown and orange. Now, the red and black is the one that comes out from here as AC current, which you can use to light your bulb. Now, but before you will be able to access 220 to 240 volts for you to light your bulb, you will need a capacitor. Now, the capacitor is this orange wires you see. It has to be connected to a capacitor. The function of the capacitor is to store energy, which will energize the current coming from here to be able to give you the 220 or 230 volts required to light this battery. If you disconnect this capacitor, you will not have enough voltage that will be able to power this battery. And this capacitor comes with a capacitance. And the capacitance for this size of generator is 24 microfarad. That is a capacitance. And if you want to calculate the energy that this capacitor can produce, we were told that the energy stored in a capacitor is a half CV squared. C is the capacitance, V is the voltage. So the square of the voltage times the capacitance of the capacitor will tell you the amount of energy stored here. And the voltage coming out from here is not up to 220 until it passes through this capacitor before it emits through this terminal. Now, the next part of the wires, which is the last one now, are these blue wires still coming out from here as brown. And it takes you to what we call a diode. This is a 4-corner diode you see here. The reason why I had to connect this 4-corner diode is because I need DC current from this alternator to charge this particular battery while it is running. Now, for me to achieve that, I need a 4-corner diode. 4-corner in the sense that it has 2 terminals for AC, and that is the one coming out from here. And then it has 2 DC terminals that will power this battery. So what happens is that the voltage that is coming out from here is quite high, about 220 to 230 volts. It will go through this four-corner diode, and a diode, as the name implies, is a rectifier. It converts AC current into DC current. So the AC current that is coming from here at a high voltage of about 200 and something volts, it will convert it to just 30 volts. I had to use my multimeter to test the quantity of voltage outputted by this rectifier. So it will convert it to 30 volt, which is required to charge this battery. And if you check the wires, you trace the wires through, the blue and the brown wire you see here are the ones that are connected here and connected here. So they are the two terminals that will charge this battery while the battery is running. Then next, in case anything happens, there is short circuiting or something happens within the generator, there is a need for a circuit breaker. And the circuit breaker is what I connected to this terminal of this DC motor. But before then, there is something very important I need to draw your attention to as far as this DC motor is concerned. This DC motor you see here rotates clockwise and anti-clockwise. When it rotates in a clockwise direction, what happens is that it goes this way, and it may be in the same connection with the shaft of this AC, of this alternator. This is experience I'm talking about. The clockwise direction, if you connect positive to positive of the battery, negative to negative of the battery, it will rotate in a clockwise direction. Now that clockwise direction happens to be in the same direction with the rod connecting the alternator and the DC motor. And because it is in the same direction, after some few revolutions, it will lose that particular rod that connects the alternator and this. And at the end of the day, it will be rotating, but you will have no current. So what I had to do was to swap the terminals of this DC motor. And as soon as I swapped the terminals of the DC motor, I was now having an anti-clockwise direction flow. So the anti-clockwise direction was now opposite to the direction of the rod here, and it will never lose. And by so doing, your generator will run as long as your battery is ready to power it. So the function of the circuit breaker here will just do the job of breaking the circuit if maybe anything happens. If anything happens, it will break the circuit, and at the end of the day, you have your appliances safe. And I have to connect two breakers. The first breaker here controls the DC motor and the alternator, while the second breaker will control the solar panel and the charge controller. So I need two circuit breakers, and they work independently. Next, this circuit breaker is what you see connected here to this. Now the essence of this solar panel is just to ensure that the battery is constantly charging even though you are not using the generator. From my research work, I have noticed that the rate at which this battery is charged by the alternator is not equal to the rate at which the DC motor consumes the battery. And because it is not equal, after some hours, the battery will die. And so there is need to always power this particular battery, even though you are not around. And that is the essence of this solar panel you see. The solar panel can come in different capacity. This is just 50 watt. You can put 200 watt, 300 watts, 500 watts, depending on how you want it to charge your battery constantly, and it will give you power. Now, if you check this vividly, you will understand that the rate at which this one consumes is not equal to the rate at which it is powering it. If they happen to be equal, then this system will run forever, and it can never go off unless you decide to switch it off yourself. And if it runs forever, one of my students made me understand that if this will run forever, automatically it is disobeying the law of thermodynamics. And of course, from my research work, I discovered that it can run forever. So you will have to look for an external source to power the system so that you can have it last you for a long period of time. So then the last part of it is this particular charge controller. The essence of this charge controller is to simply control the voltage coming from your panel before going to your battery. If not, the charge controller will overcharge your battery and your battery will die. So you need a charge controller to control the amount of voltage going into the battery. When the battery is full, it will automatically disconnect. And when the battery is low, it will automatically charge. So the charge controller does not just control charges, it also prevents your battery from running down below deep cycle. Because every battery has a particular amount of time it can run down. And if it runs beyond that number of times, the battery will die. So it will control your battery from running down below deep cycle. So that is a function of this. So the output of everything you see here is it can give you AC current. It can as well give you DC current. This is to the panel, this is to the battery, and this is to the load. And the load is this fan that I connected here. Then this one is the bulb I connected to the AC. So ladies and gentlemen, this is the job. It's a complete experimental work. I just rounded it off, and at this point I will have to test run it so that you see how it works, and then I will hope to hear from you. So first, let me start with this part. Good. I just owned this particular solar part. If you check right now, the charge controller is showing 12.7 volt, and the 12.7 volt you see here is from the battery. Now if you check here, the panel is reading 0.0, and the reason why it's reading 0.0 is surely because my terminals are not properly connected. So I will have to connect that properly and then continue from there. Alright, so it has peaked. I actually did not connect it properly because the insulating part was in contact with the screw instead of being in contact with the connecting part. So now if you check, the voltage of the solar is just about 8.4 volt. This is because in my office here it's a little bit dark, so we can't see properly. There is no light enough. So but the value of the battery, if you see there is written the battery voltage is 12.7, and then the load, which is the output, is 0. Why? Because I am not using it yet. So by the time I start using it, which is this particular one, it will start reading. So let me try and put on this so that you see what I'm saying. So first, if I click on this off and on button, you see? So the fan is blowing, and now that the fan is blowing, you'll see that there's changes in the current. The current is reading 4.5 amps right now. So the fan is still very much blowing. So this is just a load attached to this particular charge controller. So if you want to put it off, you can just click here and then it will go off. If you click back again, it comes up. This is just like off and on for the load. But if you want to shut down the entire circuit, you just come over here and then boom, it goes off. Everything goes off at this point. Now this is the DC source of the whole generator. So you can have DC on this aspect. Now we'll go to the AC aspect. So with this, you can even charge your mobile phones through these slots you see here. It can charge a minimum of 4 phones at the same time, a maximum of 4 phones at the same time. So you find them here. These are USB sockets, and they are rated 5 volts 2 amps, 5 volts 2 amps. So it can charge your phone battery easily and very well. So the next part is the AC part, which is the AC current, which you can take to your changeover from here, and you power your home entirely. So we are going to put on the generator. Everything is properly connected. So if I put on this here, it will start rotating, and boom, you will have power. So let's give it a try. And boom, you will have power. So let's give it a try. Now you see the rotation. Everything is working perfectly. So now I'm going to put on the switch here. It's on. Woohoo! This is magnificent. Now you can see it's giving you full power. And it's working just perfectly very well. You can also on this at the same time.